When we talk about AI, we use all these really weightless words.
Like the cloud.
Exactly, the cloud, neural networks. It paints this picture of something invisible, like it's just math and code floating out in the ether.
Right, like it has no physical footprint.
Yeah. But looking at the stack of sources for today's deep dive, that illusion just shatters completely.
Oh, absolutely.
I mean, the true battleground for artificial general intelligence isn't about code or silicon chips anymore. It's this massive, frankly, desperate race to secure physical power plants.
Yeah, to understand who actually wins the AI war, you really have to look at the power crisis driving it. I mean, just the baseline numbers alone reset your perspective.
Right.
A standard data center, the kind we've had for years, used to run on about 32 megawatts.
Okay.
But now, an AI-specific data center demands 80 megawatts just to open its doors.
Wow.
Yeah. And on the consumer side, a single ChatGPT query takes almost 10 times the energy of a traditional Google search.
Wait, 10 times.
10 times!
Yeah.
And that is just everyday operations.
So when we look at the hyperscalers, the massive cloud providers pushing toward artificial general intelligence, it requires this brute force computing on an unprecedented scale.
Right, and you can see the sheer panic about this energy deficit in what OpenAI and SoftBank and Oracle are doing.
This is Project Stargate, right?
Exactly. They're dropping $400 billion to build this ultimate AI grid. They're aiming for 7 gigawatts of power.
It's so wild.
Their flagship facility in Abilene, Texas alone is slated for 1.2 gigawatts.
To put that 1.2 gigawatts in perspective, I mean, that is enough electricity to power every single home in a city the size of San Francisco.
Yeah.
Just for one single data center. And the bottleneck here is that they are trying to hook these massive facilities up to our aging U.S. power grid.
Which is an absolute nightmare.
Right. It's like trying to power a stadium rock concert through a single frayed extension cord.
That is a perfect analogy. And the biggest problem with that frayed cord isn't just its age.
What is it, the regulations?
Yeah, it's the decades of red tape wrapped around it. Getting a new gigawatt-scale facility approved, permitted, and physically hooked up to the public grid can take 10 years of infrastructure delays.
10 years.
Right. And big tech simply cannot wait 10 years to plug in their servers, so they are forced to find immediate workarounds.
Because they need power today. So they start buying up off-grid natural gas turbines just to run their data centers right now.
Exactly.
But wait, let me play devil's advocate here. If off-grid power is the answer, and these companies have like virtually infinite cash, why is this even a crisis?
That's a good question.
Couldn't Microsoft or Meta just buy the biggest, most heavy-duty industrial generators on the market and just call it a day?
Well, that is the logical assumption, right? Until physics violently intervenes.
Physics.
Yeah, the physical reality of AI training is completely different from traditional computing.
How so?
Normal data centers draw power on a steady, highly predictable curve. But training machine learning models creates these wildly unpredictable power demands. The servers instantly demand a huge surge of electricity and then drop it just as fast.
So the software causes electrical spikes. But how does that destroy a physical generator?
Okay, so when an AI model processes a massive data batch and demands that sudden surge of electricity, that electrical draw actually acts like a massive brake.
Oh, I see.
It creates immense magnetic resistance on the spinning generator. So the gas engine is forcefully pushing the heavy metal shaft forward,
Yeah.
but the sudden electrical load yanks it backward. That opposing torque literally warps the solid metal.
Wait, really? They are physically twisting the solid metal shafts inside the turbines?
Yes. Generators that are built to last 5 to 10 years in normal industrial settings are just tearing themselves apart.
Oh, man.
They're self-destructing in under 12 months. Big tech is burning through heavy industrial machinery just to feed their models.
That is an incredibly brutal, completely unsustainable fix.
Very much so.
So with the public grid tangled in a decade of red tape and off-grid gas turbines literally ripping themselves to shreds, what's left?
Well, the industry's running out of options. That desperation is pushing them toward the only reliable long-term solution left.
Which is going nuclear.
Exactly. They're going nuclear. We're seeing Microsoft reviving a 20-year deal to buy 837 megawatts from the infamous 3 Mile Island plant.
Wow.
And Amazon is securing 960 megawatts from a nuclear facility in Pennsylvania.
But buying up legacy plants has to be only a stopgap, right?
You're right. The real end game, according to the sources, is SMRs, small modular reactors.
Right.
Google is backing companies to build these advanced SMRs, and Meta is plotting a 1.2 gigawatt campus powered entirely by them.
But why pivot to experimental nuclear reactors instead of, I don't know, building out massive solar or wind farms?
It really comes down to uptime and physical footprint. Renewables just don't match this specific profile.
Because of the weather dependency.
Yeah. Solar and wind only produce power about 25 to 35% of the time, depending on weather and daylight. Okay.
AI requires 247 uninterrupted power. If the models stop, the training fails.
I see.
Plus, a traditional solar farm capable of that massive output requires thousands of acres of land.
Right, which means long transmission lines and fighting through all that grid politics again.
Exactly.
Yeah.
But an SMR, it could be dropped onto just 50 acres directly adjacent to the data center.
Wow. So the winner of the AI war won't just be the company with the smartest algorithms or the most efficient silicon chips.
Not at all.
They are going to be the new utility barons of the 21st century. It's no longer just about software. It's about real estate and raw power generation.
Which leaves us with a really critical question regarding our own infrastructure.
What's that?
Well, if big tech successfully acquires legacy nuclear plants and builds out its own massive private nuclear energy grids, what happens to the rest of us?
Right. What happens when everyday citizens and public utilities have to compete with the insatiable power appetite of AI?
Exactly. Will we be left in the dark? It really reframes the whole industry. That invisible, weightless cloud of code we always picture.
It's a lot heavier than it looks.
Yeah, it turns out it's actually anchored by twisted metal, massive cooling towers, and radioactive cores. Definitely something to keep in mind the next time you type a prompt.